Hey, Ryan here. In this video, we'll delve into dramatically simplifying TypeScript backend development, focusing on pure TypeScript without relying on multiple libraries or frameworks. Our strategy involves a single small file importing Express, with other components being pure TypeScript functions. This approach isn't just easy to implement, it also improves interactions with the frontend. Having switched from a GraphQL API to this approach, I can attest to its directness and appeal to front-end developers. However, it's crucial to identify the appropriate audience for our API. For a public API serving diverse clients, GraphQL or REST APIs are recommended. In contrast, for an API designed for a singular application, which is often the scenario, this technique proves to be highly effective. Let's get started. In this tutorial, we'll examine Increaser codebase housed in a private repository. However, all reusable code pieces are accessible in the React Kit repository. Like many applications, our front-end app requires a backend to interact with databases or other server-side services. Direct database calls from a user's browser aren't feasible, necessitating an API middle layer. This layer processes requests from the browser, converts them into appropriate database queries, and returns results to the client. Communication between the browser and API occurs via the HTTP protocol. Commonly, REST or GraphQL formats facilitate this communication. However, we'll explore a simpler method, using the URL to specify a backend function name and pass an argument to this function via the post request body. Now let's transition from theory to practice. In our monorepo structure, we define the API interface within a dedicated package named API interface. The centerpiece of this package is the API interface file, which enumerates every method our API offers. Different from the GraphQL structure, our approach consolidates all methods in a single list, removing the typical division into queries and mutations. The API method interface is utilized to define the input and output of each method in our API. In instances where a method lacks either input or output, we employ the undefined type. Frequently, we repurpose our existing entity models as input and output types, selectively choosing fields through the use of TypeScript's pick or omit utility types. Within the API package of our monorepo, our task is to implement the interface defined in the API interface package. To achieve this, we start by creating an API implementation type. This type is situated in the resolvers folder inside our API package. The API implementation type functions as a mapping, where each method name is associated with a corresponding resolver function. These resolver functions are designed to receive an input that is associated with a specific method name and the context of a request. They are responsible for processing this information and returning the appropriate output. In the index.ts file located in the resolvers folder, we actualize the API implementation type. This is accomplished by constructing a record that encompasses all the resolver functions of our API. Consider this example of a resolver for the update project method. This resolver extracts the user ID from the context and utilizes it to update the corresponding user's projects in the database. The assert user ID function is designed to verify the presence of a user ID in the context. If the user ID is found, the function returns it. Otherwise, it triggers an API error. The API error class situated within the API interface package serves a crucial role in our API's error handling. It categorizes and communicates the nature of errors that occur during API calls. On the front end, these errors are then handled appropriately. For example, if the assert user ID function identifies an invalid auth token error, the front-end logic will respond by redirecting the user to the login page. In this key file where we integrate Express, we begin by initializing a router and setting it up with a JSON parser. We proceed by iterating through our API methods. For each, we set up a dedicated route, handle the input processing, extract the necessary context, and then call the responsive resolver function. For transforming request headers into a resolver context, we employ the getResolverContext function. Leveraging our CloudFront setup, this allows us to extract the country code directly from the CloudFront viewer country header. Additionally, we retrieve the user's GVT token from the authorization header. The extract header value function acts as a straightforward helper designed to retrieve a header value from a request. It's important to note that in the headers object, all keys are in lowercase. Therefore, we must convert the header name to lowercase before attempting to access its value. The safe resolver is another small helper function that will return a fallback value if the provided promise rejects. The user ID from token function is responsible for extracting the user ID from the GVT token. It does so by verifying the token signature and returning the decoded user ID. When encountering an error while resolving a request, we initially determine if it's an API error. If not, this indicates an unexpected issue, which we then report to Sentry. Furthermore, for unexpected errors, we also return an API error, but with ID set to unknown. This approach ensures that the frontend can consistently discern whether the error originated from the API by checking the ID field. If an error lacks an ID, it suggests a network-level problem, not an API issue. Let's shift our focus to the frontend to explore how this API can be initialized. Within the app package of our monorepo, there is an API folder. The core component of this folder is the call API function. This function accepts the base URL of our API, a method name, input parameters, and an optional authentication token. It returns a promise that resolves with the output of the specified API method. To construct a URL for an API call, we utilize the join_path function. This function merges the base URL and the method name, ensuring that there are no duplicate slashes. Next, we construct the headers for our request. We set content type to application.json. Additionally, if an authentication token is available, it is included in the headers. We then utilize the native fetch function to make an API call using the post method, passing the input at the request body. If our API returns an error, the response.ok property will be set to false. In such cases, we try to extract the error message from the response body using the async fallback chain function. This helper function sequentially executes the provided function, returning the result of the first successful execution without errors. If all functions fail, it throws the error from the last attempted function. Initially, we attempt to extract the error message using the response.json method. If an ID field is present in the response, we construct an API error instance identical to the one used on the API side. In the absence of an ID field, we return a generic error with the response body as its message. However, if parsing the JSON response fails, we then resort to the response.text method. Although this method is unlikely to fail, as a precaution we have response status text as the final fallback. Finally, we employ the safe resolve helper once more. This is because our API may sometimes return no response, causing response.json to fail. By wrapping response.json with safe resolve, the function returns undefined instead of throwing an error in such scenarios. To facilitate comfortable interactions with the API from a React component, we require hooks. The primary one is the useAPI hook, which will return an object with a call function that we can invoke to make an API call. In this setup, we retrieve the base URL from the environment variables. As our application is a Next.js project, we prefix it with next public. We then utilize the useAuthSession hook to obtain the authentication session and a function to modify the session. For more information about authentication in Next.js or React applications, consider watching my videos on OAuth authentication and Magic Link authentication. The call function, similar in signature to the call API function, omits the base URL and auth token parameters, since these are supplied by our hook. Upon encountering an error, the function checks if it's an API error with an invalid auth token ID. If this is the case, it clears the auth session. This method is effective for managing situations where the user's token is either expired or invalid. To enhance our developer experience, we've implemented the useAPI query hook. This hook accepts a method name and input, returning a React query. Additionally, this file includes a helper function, getAPI query key, designated to generate a query key for React query. This key can be subsequently used to invalidate and refetch queries impacted by mutations. Observe the ease with which we can query any data from our API using just a single line, as demonstrated in this example, where we query a scoreboard of the most productive users. Lastly, there is the useAPI mutation hook. This hook takes a method name and optional options and returns a React query mutation. Here's an example demonstrating how we can utilize this hook to update a user's profile, followed by providing a callback to refresh the scoreboards upon successful update. That's all. If you found this video useful, please like and subscribe. Become an effective 10x programmer with my productivity app at increaser.org.